You can get your stuff certified to be IPv6 ready. That's what this logo is. Theoretically, you can get your courses certified as IPv6 compliant. I've tried to do that and I couldn't get any answer out of anybody. Just like I tried to join InfraGard so I could get an established presence within the FBI, which is what you should do if you're in network security, so that they know who you are. And again, I get no answer out of anybody. So in principle, there are these programs. In practice, yeah.
What was the name of that?
InfraGard. InfraGard is the public-private partnership of the FBI. It is highly recommended to be in it. What people tell me is the only way to actually get in is not to, yeah, let me bring it up. If you're into network security, you ought to join this group, and I'm telling all my students to join it, because sooner or later something really bad will happen. You'll find something horrible on your network, like kidnapping or child porn or something. Then you're going to have to call law enforcement, and if they've never heard of you, they're going to think you're probably the perp. And that's going to be a barrier you have to overcome. So you want them to know of you as a legitimate good guy first. So that's what InfraGard is for, from my point of view. If you join InfraGard, they'll make you sign a big, scary non-disclosure agreement, so claiming you won't tell them about all the secrets the FBI will tell you, but everybody tells me that is nonsense. The FBI never tells anybody anything. The whole point of the FBI is information flows one way. You tell them stuff and they never tell you anything. But anyways, this is a good thing to join. And they have meetings, and I want to take my students to it and everything. So what people told me now is just go to the meetings without having joined is the only way to actually really get in. There's a lot of dirty little secrets like this. I remember I spent a year trying to get a job as a college teacher by applying at the HR department until I finally remembered a dinner conversation with my parents 20 years ago, and they said, you'll never get a job that way. You have to go to the department head's office 3 weeks before class and they'll pull you in. The only purpose of the HR department is to make it seem like they're open to hiring from the outside, which they aren't. And that's certainly true. So anyway, as far as I can tell, the official procedure to join InfraGard is similar. It is some kind of formality it's an intelligence test to see if you're dumb enough to do the official, anyway. But it is good to get involved with this, because then I would like to have somebody in the FBI I can call and ask questions. I already have questions I like to ask them. You want to have a friendly voice inside law enforcement to find out what's, for example, some people thought I was already in big trouble when I started chatting with the jester. And they said they're going to keep the logs. The jester's the guy that brought down WikiLeaks. I go in the chat room while he's doing this. I'm trying to talk him out of it. But they say, you're going to mark you as a black hat hacker. You're conspiring with him and everything else. And I said, this is not one of those occasions. It would be nice to have a friendly ear inside law enforcement, so I could let them know what I'm doing and why I'm doing it. And they can tell me what they think about it, without necessarily already being me arrested and interrogated, and the more you get into network security, the more it seems like a really good idea to have a known presence as a good guy. This is just the Cisco presentation of the similar stuff. You've got this time to live. Now, a question came up at lunch, which would be kind of fun to test. Some people have got this stuff up. They say in the official documentation that neighbor discovery works by setting the hop limit to 255. So it'll only go one hop. But that seems backwards. It seems like setting it to 1 is what you ought to do, because it ought to be decremented. Maybe it's incrementing instead of decrementing. I'm not sure. We should try it here and see. Anyway, it is 255. So, by the way, one thing I don't think I mentioned before is that supposedly layer 4 doesn't change, except ICMP changes, but TCP and UDP, in theory, are not supposed to know or care whether they're going IP version 4 or IP version 6. But I think there are some fields in there that change values to show you what's actually inside. Fragmenting we talked about. The authentication and security we didn't talk about much. IPsec has an authentication header and an encapsulating security payload, and it's quite a job to set up, especially with the key management. But it's people are already setting it up on IP version 4. So even though it was originally an IP version 6 thing, it's not exclusive in that range. You know how to shrink your addresses, so this whole mess goes down to that. There's just a Cisco presentation of it. Here's a kind of nice diagram. Here's to the link local addresses. Go only on the directly connected link, like a layer 2 address, the FE80s. The unique local are the FC00s, which are able to go through your enterprise, but they can't route on the internet. And everything else is global. There used to be another category called site local, which was, I think, between here and there, and they never could explain to anybody what a site was. And they finally just deprecated it and forget about it. A few years ago, there were 4 categories of addresses, something different between unique local and site. And global, that's over. But that's why there are several actual address ranges that are deprecated because they've been used for purposes that are gone. So the site local addresses are deprecated, and there's the 6 bone addresses are deprecated. There used to be a temporary internet backbone for version 6 called the 6 bone, which is not used anymore, but the addresses are not supposed to be used. Yeah, here we are. F, E, C, D, E, and F are the site local. So you shouldn't be using those, in theory. All right. If you have multiple IPv4 addresses, that can be a drag. But IP version 6 is expected to have multiple connections all the time. Everything is supposed to be multi-homed. You're supposed to be allowed to have multiple unique globally routed addresses on the same interface. In practice, people tell me that doesn't work very well with real clients that are currently existing. I haven't tried it, but that's why people think they need NAT 6 to 6, because you can't put multiple public IP addresses on the same interface the way you're supposed to. You should be able to get internet service provider from service from one ISP and service from another ISP and double address every device, and you can both just choose which one to use. But that is more than the people who wrote the client operating systems really thought they would have to do, is to choose which of multiple connections to use, and so it's not actually working too well. What's that?
Okay.
Yeah.
It's been modified, but some of it is minus, some of it is his, and some of it is John Berkowitz.
John Berkowitz?
His name's in it too.
Yeah. Well, you want to know, some of it's yours and some of it's written by the, yeah. Okay. Yeah. Anyway, so in principle, you can have multiple addresses here and go to 2 different ISPs, and the end device is supposed to be smart enough to figure out which one of these to use. I have not tried it. Like I say, I've been told that it doesn't actually work if you try a typical modern operating system. All right. So assigning the address, auto-configuration is the way you're supposed to do it, which was not present in IP version 4. So the router sends a router advertisement packet. And that just gives you the first 64 bits. Your end devices make up their own addresses, and that's SLAC, stateless auto address auto configuration. All right. So wait, wrong way. All right. So here's the game. It sends network info. You'll see these RA packets flying around in your network. And the elephant in the room here is there's no way to distribute the DNS address. So you need DHCP anyway, just for that, which seems to be a serious logic flaw in the planning, but that's the way it is. That's stateless configuration. You can also, of course, put on static addresses, just like you can with DHCP. You can put static addresses on devices, and it will just notice if the address is already in use and work around it. And the same thing's supposed to happen here. That's the process we've seen before. There it explains in more detail about that 1 bit, which has a special meaning in a MAC address and in a SLAC address. But for most practical purposes, it doesn't matter. So here's how you do it in the Cisco world. IPv6 unicast routing has to be turned on, or you can't route IPv6 packets at all. And then you can just assign your address here. IPv6 enable on the interface, and that will do it. And then you'll be doing that in your packet tracer assignments. There you'll be assigning IP address interfaces. And show IPv6 interface brief will then show the addresses, and everything will have 2 addresses, an FE80 and a public address all the time, just like you're probably getting used to by now in IP version 6. All right, so your globally routed addresses are generally 2001s. Remember, all the 2s and all the 3s are available for this purpose, but probably for the remainder of our lifetimes, we will not run out of 2001s. So they may never get around to the 3s for a long time. FC00 is what's recommended for links between routers, because remember, those are local addresses like 10 dot something, and you might as well use local addresses because you don't want any traffic from outside your network addressed directly to the point-to-point link between routers. That's kind of weird anyway. One thing that you could do in IP version 4, and I think it should be independent, you can have point-to-point links with no IP address at either end. You can make it run just at layer 2. There was a, but anyway, that's not common. People usually do put FC00s on them. By the way, there's been actually a debate here. Some people would like to use /127s for point-to-point links. So there's really only 2 addresses. By the way, if you remember your IP version 4, you normally use /30s for that, because you can only get 2 usable addresses because you can't use the first or the last address. But that's not true in IP version 6. There's no broadcast at the last address, so you can use it. And apparently you can use the first address too, because some people do advocate and use /127s for point-to-point links. However, the most authorities say just use a slice 64 even for the point-to-point links. But if you really want to, you could use any prefix you want. It's all local. This is not routed on the internet, where it'd have to be a slice 64, so you can do anything you want. But most people say just stick the slice 64s throughout, and that way you won't have to go nuts. And so that's the game there. Here's the 128-bit auto configuration. So you have the unique global part is you have 48-bit MAC. Whatever it does to develop that address, it will then do a DAD process, duplicate address detection, to make sure no one else is already using it. So that's the game. Auto configuration is in principle making it possible to plug and play with end devices, except for DNS, which is just not mentioned. And so DHCP is the alternative. You do have to use manual address on your routers, which is also pretty common because you don't want them moving around. There is no fixed deadline for converting IPv4 to IPv6, but there is, of course, the impending exhaustion of IPv4, which will cause people to either have to use private addressing and NAT for all the future ones, or obtain used IPv4 addresses. Now, and you brought up an interesting question during the last lab time. I sort of wanted to throw back at the class here. So he's got a bank that has used an address space, like 10.0.0.0/16 and 10.1.0/16 or something. And he buys another bank that buys it that has used exactly the same addresses. Now what? Is there any way out of having to renumber one whole bank and take it down? I would like to say no. Does anybody know the answer? If you use the same private address space at two companies, now you want to merge them into one LAN. On the routers, you just have to renumber one whole company, right? Is there a brilliant solution in the middle? Nothing forthcoming immediately. In IPv6, this is supposed to happen all the time. You're supposed to solve it with no problem. Every time you change ISPs, you're supposed to have to renumber every device, and you're supposed to be able to do it by using nothing but the RA package. That's what people say. I would like to see what really happens, because this is going to be a common problem, because if ISPs come and go, and it used to be your ISP comes and goes, you keep your addresses, but they're not supposedly going to allow that. Anyway, so dual stack is both of them together. You can use IPv4 to connect IPv6 end devices with tunneling, and you can do the opposite, which is discussed a lot in theory, although of course it's not the practical issue now, but there will come a time when you only have IPv6 internet service, and you have IPv4 legacy devices here that want to talk to IPv4 legacy devices here, so you're going to have to tunnel 4 in 6. The most common thing right now, of course, is what we're doing here, tunneling 6 in 4 with that GoGo client. But it's all going to happen, and so you'll have to connect from one type to the other as you hop around. So here's the addresses with the embedded IPv4 in them. 6 bits, 6 fields of hex followed by 4 octets. All right, and I think we've talked about this. This is just a way of putting an IPv4 within an IPv6 address for local purposes. These things aren't routable. And here's another way to do it. Those are not routable either. And IPv6 subnetting. You can subnet to anything you want for purposes of putting it in a routing table. So you can have a slice 48, which is what your ISP should be giving you. So then the first 3 fields determine your company. The next 1 field is for you to make subnets, and this is all for your auto configuration, just fill with random numbers on each device. That's the plan. So in the packet tracer towards the end, I made a company sort of little diagram there, and I said I take 2 digits here for the company location and 2 digits here for the subnet within that company, and then use the rest to be random. But you'll have to come up with a pattern at your company of groups and subgroups and how to split up the addresses so you can number things correctly. Otherwise you will get confused. Just the administrative effort of grouping your stuff and numbering them correctly is quite a big job, and I think there's a couple whole chapters about it in that book there. Yeah?
So Sam, the global unique 2001,
Yeah.
that is always, 2512 is always the same, will always be the same.
Yeah.
What is recommended?
Well, if it's if you get it from an internet registry,
Okay.
then it will be drawn from their pool, and I think the North American ones are here.
All right.
But I'm not quite sure. There are different versions.
So, but they the one who provide you that initial.
Yeah, your internet service provider will give you this. This is like a public IPv4. So this part you don't control. They give it to you. And then this part you control for subnets, and that part you control.
Which is your 64-bit.
Right. This is the 64-bit switch, is intended to be used only by those devices. So the only thing you really have to choose is how you're going to do this. Unless you use manual addressing over here, which is if you're really strange enough to use something other than /64 size subnets. All right, and that's right, no more reserved node, no more 2 to the n minus 2, just 2 to the n. The first one and the last one are not reserved. So that's the game. The registry has a /23. Your ISP goes out to here. ISPs get /32s, and then they get to hand out /48s. So your ISP can only have 65,000 companies that can serve unless it has to ask for more. Really big ISPs can get more. And here's your subnet prefix. That's the plan. All right, and there's the global routing prefix. We've been here before. The SLA, the site level aggregator, that's your subnet ID assigned to a, right, this is your service provider. So your service provider has numbers up to here. They split it up into each of their customers gets one of these SLAs determined by the ISP. Then you choose to number your LANs, and there's 64 bits for the interface. That's the plan. All right. I don't think there's anything more new there. And so hopefully we'll get some clarity here about the 2001, 520. Yeah, here's like just an example. Yeah, 61 global network bits because the first 3 are always 001. Nobody can change them. 64 host bits. It is possible, but not recommended, to borrow host bits. All right. And hopefully it's obvious that you will never need to expand your subnets. Each one has 2 to the 64 addresses. All right. And that's the game. There'll be a large set of providers here with different multiple levels in it all. We're going to see how this all works out in practice. As you can see, if we're inefficient enough about this, we could in fact run out of addresses. And in fact, even in, I think it's in this book, when they start talking about managing a large company, just like, you know, you ask, why is the serial number on your car or something 25 digits long? Because they're just not very efficient, right? The first 3 digits for the location, next 3 digits for the company, next for the branch, until you've used it all up. And if you're sloppy about this, you end up wasting all the numbers. It's pretty easy to make up a scheme that's 4 or 5 levels deep, and you want to put 8 or 16 bits on each one, and now you actually run out of bits. So that has kind of been left up in the air, and we're going to see what happens in real practice. You can use aggregate routes, and you certainly are going to have to because there are so many of them. They're big on the, and the same thing is supposed to happen with IP version 4. That's when CIDR came out. They said CIDR might make the routing tables smaller because it allows you in principle to aggregate your class Cs up into /22s and /20s. But of course, that wasn't the main thing it did. The main thing it did was let you cut your /24s into /27s and /28s, so it made the routing table much bigger. But anyway, if everybody stays neat and tidy and you can use aggregate routes, then of course the routing table is small and efficient, but that's contrary to the law of entropy. Yeah. All right, so your routing table will have a /35 there, /48 to a customer, a /48 to this customer, but a /35 to all those customers that nicely stay connected to the same ISP. Yeah.
What does the law of entropy say?
Oh, the increasing entropy. You know, it's just a simple way of counting. It says that things will get messy, they will not spontaneously get neat. So entropy will always increase. And if you actually neaten up something, you do it by expending energy, and that messes up something else even more. This whole universe will just constantly get more and more disordered. It's inevitable. That's the law of entropy. So I mean, anybody can tell you, if you have a bunch of dice and they're all ones, and you shake them, they will have random numbers on there. And no matter how many times you shake them, they'll never come back to ones. That's the plan. So, of course, when you make a new system, it starts out neat, but it will naturally mess up. Unless you have unless you really have rules enforced by someone that can really make you obey the rules and stay between the lines. And I don't know who thinks you can do that on the internet, but apparently IANA thinks that. Yeah.
A network wiring closet is a perfect example.
Yeah, it is perfect. Tim had good pictures of that. He had pictures of our City College network, our racks. You know, just a horrible mess. Then we just replaced everything. Now it's all neat. But of course, it'll get messy. Of course, it's the same thing. As you change, changes are in the direction of more mess. Until you have a big effort expended to neaten it up, which creates some waste product somewhere. So total amount of mess in the system just goes up and up and up to more messy. It's inevitable because there are more messy states than neat states. That's the essential argument. It's just a statistical point. Like breaking something, there are a large number of broken states, but only one unbroken state. So motion of any kind will move into the more broken states. Anyway, an artificial human creation like mathematics can possibly violate that law, but only if people actually obey the rules. And I don't see any firm, decisive, authoritative, harsh body at the top here to make everybody obey the rules and stay in line. And indeed, we wouldn't want that, right? Because whatever the rules are, breaking the rules would be the way to make the next cool thing. All right. Anyway, we've seen that. That's the subnetting there. You can use the one in the middle to split yourself into networks. All right. And you've got a lot of hosts. So if here's your subnet, you can go from 1 all the way to FFFFFFFF. So, you know, there's enough addresses there that you can go forever. All right. And there are some tools to help you do these calculations. There are subnet calculators for IPv6 available on the web if you want them. All right. But you're going to want to assign them in a hierarchical manner. Now, it all comes from, you're going to have to get your addresses from an internet registry, like IANA or ICANN. So you can get them from regional internet registry, of which there are these 5. So for us, it would be Erin. And you get them from there. Now, they cost money. Somebody told me this recently. They cost something like $100 or $1,000, and you have to pay an annual maintenance fee to get a Class C right now. So I guess there will be some fee associated with getting your IPv6 allocation also, but not a very large one. So here's how it goes. IANA hands them out to here, their regions, and then they hand them out to lower level internet registries, which will give them to you. Ultimately, most customers get them from an internet service provider, but they're ultimately all coming from IANA and Erin. So here's some allocation blocks. There's the 2000s are out there, and the 2600s are out there. I don't know under what conditions they hand out those 2600s. Everybody I know is getting 2100s. 2001s, thank you, 2001s, not 2100s, that's right. So here's some tips in how to do it from Cisco. Or the alternative, you can use 6 to 4. Remember, if you have an IP version 4 public address, you already have an IP version 6 public address assigned to it. It's connected to it. And if I had a machine with a public endpoint address here, I could demonstrate it. But it connects through a tunnel, which is 192.88.99. All right. And you can ask for more than 48s right now. There may come some time when you can't. And here's 6 to 4. That's the 2002. Take 2002, put in 32 bits of your current public routable IP version 4 address. That gives you 32 plus 16, that's 48. That's your new IPv6. And you've got a /48 you can use. So if your company already has even one IP version 4 public address, you already have a whole /48 to use. And you can use it if you like. This gives you a 6 to 4 gateway, though. There are open 6 to 4 gateways running out there. It's very disturbing, actually. They're wide open just like the old mail servers were open. I don't know how long that's going to last, but it's true right now. All right, so that's the plan. You get a /48. Now, in principle, they can give you a /56 or even a /64 if you tell them you're small and you're never going to grow and they actually buy that, which would be contrary to the law of not messing up the thing, because if you gave some clown a 64 and then they became popular and now they needed a 48, now you've messed up the routing table. But anyway, we'll see what becomes of that. All right. And that's the game. They'll just give you the next block.
I don't know how you can fit up a 64.
What's that?
How can you route of addresses at 64?
Well, you can have a /64 in the routing table on the backbone, and apparently there are conditions under which ISPs will actually do that. They'll sell a 64 to one customer because they tell them this is just for one station, it will never grow, but that doesn't seem wise to me. I haven't seen how it's really going to happen. 48s are the main thing you're supposed to get. All right, and so here's the types: unicast, multicast, and loopback. And there's also anycast, which is used, as far as I know, only in IP version 4 to reach the 6 to 4 gateways. But in principle, it would be nice. You could have like an anycast to reach the Sprint network, and it would be anywhere in Sprint will be fine because let Sprint sort it out from there. If you have multiple points of presence to get to the internet, an anycast with any of those addresses would be a logical way to reach you. The routers don't even need to know what's happening. But anyway, it's
That loopback is printable, right?
what's that?
That loopback is printable, right?
An anycast?
No, the loopback.
Loopback is pingable, absolutely. Loopback is pingable, and so is the unicast, which is the main thing, unicast routing. Multicasts, I don't know if they're pingable. I kind of think they shouldn't be, for the same reason we didn't forward broadcast pings, but I haven't tried it to see. It'd be fun to play with those Anycast addresses. There's quite a few interesting ones. There's an Anycast for all routers, an Anycast for all nodes, and there are other ones. So a multicast, there are multicasts for those. It'd be fun to play with them. Anyway, so the multicasts are assigned, and your nodes are supposed to join them with ICMP version 6, replacing IGMP. Unicast is the main kind you use, of course. And then Anycast are over there. I have no real experience with using those, and I don't think anybody does have much practical experience with using IPv6 Anycast yet. We'll see what good it turns out to be. But the protocol permits it. All right, so there's the link local address used by Neighbor Discovery Protocol. And it's made up here. All right, we've talked about this stuff. FE80 and the next 56 bits are 0. We've been through this before, how you make it. And here's the global unicast addresses. See, a lot of this we've already covered, but this is the Cisco way to cover it. So there's global unicast 2001. This is what you're getting from your GoGo 6 tunnel right now, then a number here, and then 16 bits for you and 64 coming afterwards. All right. So there's IANA. So here's the game. 2001 is the practical IPv6 interface. 2002 is for the 64 transition nodes with the IP version 4 address stuck in them. And here's Sam Bowne, I mentioned before, 3FFE. That was the original test IP version 6 network, which has been abandoned. And so you're not supposed to use those. They're deprecated now to use them. And all the rest, all the 2s and all the 3s are not used yet. And there should be no hurry to use them until you think of another category, because you're not going to run out of these, or so they say. We will see. There's certainly enough addresses, but are they organized neatly enough? If you think of containers and subcontainers and subcontainers, and you give each one of them too many bits, then you could, in principle, run out. So there's Anycast is 1 to nearest. You can send a packet, and it will go to the nearest of the addresses that match that pattern, which is what the 6-to-4 relays do. All right. There's the loopback. We've been through that. There's the unspecified address, all zeros. And here's the IPv4 compatible addresses which you use in transition in your local network, which just recast, add 96 zeros to your IPv6 address. So you can have an IPv4 network and an IPv6 network and a router here that converts between the two. Now, you already set one of them up, right? What you're saying?
No.
Oh, okay.
A tunnel.
A tunnel, okay. Tunnels are what you usually have. You have 4 here and 4 there, and you tunnel through 6, or you have 6 here and 6 there, and you tunnel through 4. Converting 4 to 6 is another game everyone's going to need pretty soon. Yeah.
We went from a 4 to a 4, we just sent the traffic through an IP version 6 tunnel.
Right, right. Which is just the opposite of what we're doing here, 6 to 6 with 4 in the middle. What that GoGo client is doing 6 to 6 with 4 in the middle. Your local Windows 7 machine is running 6. You could even, and it's tunneling through IP version 4 infrastructure to 6 servers at the other end at GoGo. All right. So that's the summary of the whole thing. The zeros have the unspecified, the loopback, and the IPv4 compatible, and on you go. Here's the unassigned ones. Here's the ones you're going to see on the internet for public addresses. Here's the FE80s. And the FC100 are here in unique local, which I think that must be a typo on this slide. That should be FC, not FE, I think. There's got to be a mistake on this here official slide from Cisco. But it should be FC00, right? FC, right? Yeah, it shouldn't be FE. Anyway, all right. And multicast at the end. And those multicasts are kind of fun. F, a whole lot of zeros, and then like a 2 on the end. I think that's all nodes. FF, and then a 3 on the end is all routers. I might have that a little bit, I'd have those backwards, but it's something like that. So to do it on your router, you got to have IPv6 unicast routing. It is included in all modern OS versions, so that's pretty nice. Cisco Express Forwarding might be turned on. I haven't played with it to see what difference it makes. Supposedly that's better. Anybody tried this?
It's by default.
It's by default on CEF, so when you do this, it includes that?
I think that's the button.
Okay. Anybody know what it does? You know?
It just, the SEP is just
It just makes it faster. But do you know how it makes it faster?
probably the processing. And not only mechanic of it, but that's what it, looking at the way Cisco Express forwarding is look at certain field,
Mm-hmm.
and then just
Oh, so sort of like I described before, like flow routing. Oh, so it will. Oh, that's a good idea. So Cisco has implemented a version of flow routing. Oh.
just look at specific field and it's just no it matches just forward.
Well, that's a very good idea, and I was unaware of that.
Because
Okay.
basically you maximize your processing CPU consumption.
Yeah.
That's what it is.
Well, that makes sense. So it actually notices the chain of packets are going the same place. It doesn't bother doing the routing calculation. Well, that's a good idea. I'd like to hear more about that. All right, to configure your interfaces, you just have the same thing you'd expect, int IPv6 address, and then you put in your number. You can just put a slash here and the prefix right there like that. No more. You're not going to try to figure out what a subnet mask looks like in IP version 6, 255, or give yourself a headache. Just use the slash number, which as far as I'm concerned is what it always should have been in IP version 4 anyway. Now we just type it in that way. That's nice. So here's an example. Just put it right in here. FEC0 : 2:34/64. That's the way to go. There's your loopback. You can just make loopbacks and give them an address the same way you do. They typically give them /128s, just like you typically give IP version 4 loopbacks /32s, because you just want one address. You just want to ping it. You don't need to have any more addresses assigned to it. Here's the EUI64 version. This will tell it to use the EUI64 system of creating the remaining 64 bits out of the MAC address. That's the game of that one. You can do that if you want to use EUI64. I'm really not sure why you would use those on a router, but you can if you don't want to use statically configured ones. You have to enable it on the interface. That'll give it a local address. And I think I've just got links here. But if you go through the packet tracer projects, there's quite a bit more about configuring it. And one thing that I wanted to mention, although it's not on these abbreviated slides, is that RIP for IP version 6 is much easier to configure than RIP for IP version 4, and because you don't have a network statement anymore. I don't know why they didn't do it this way in IP version 4. You just configure RIP per interface. You turn on RIP on this interface and it goes. Turn on RIP on that interface and it goes. There's no this nonsense where you have network statements. You have to figure out what network statements to put in, and then you have to define passive interfaces. You just put RIP on the interface or not. So that's harder to get wrong, takes less steps, is easier. So try it in the packet tracer if you're into the Cisco stuff. And I think we have, so I got 3 students to add to my Sages. Anybody else make Sage? Oh, good. Let's see, I got, what's your handle? Let me get my pen, which I seem to have lost. Here it is. Wait, this. All right, what's your hurricane name? J-I-M-M. Eeks. Okay, good. I'll put you on the list. Good.